recent report conducted by Virginia Commonwealth University. The Virginia space industry contributes about $7.6 billion in annual direct economic output and directly supports as many as 30,000 jobs in the area. And it turns out Wallops is an ideal location for launch to the space station and low Earth orbit insertion. And Orbital actually has a fair amount of experience launching from Wallops. We've conducted 4 Minotaur launches to date from the Wallops Flight Facility and the Mars Launch Complex. In addition to the Antares mission scheduled for this year, which we hope to have 3 of them, we have 2 additional Minotaur missions planned to launch from Wallops, the NASA LADEE mission in August, and the Air Force ORS-3 mission in the September timeframe.
It's a pretty challenging schedule, but it's, as you showed in some of the earlier video with the horizontal integration facility, it's pretty packed in there too, with a lot of hardware that looks like it's pretty close to being ready to go.
Yeah, we've actually had 4 booster cores at the launch site here for a little while.
So by the clock, we're under 24 minutes to our opening of our 10-minute launch window. The window reduced to the 10-minute point just a few minutes ago, and that protects for a launch between 5 and 5:10 p.m. Eastern Time there on the East Coast. Once we get past the final poll that John mentioned at 12 minutes before launch, about 2 minutes later, the medium flow chill down will occur for the main engine system, for the main engines themselves. And then about 3.5 minutes or so before launch, we'll transition to terminal count, which essentially is the point where the auto sequencer is initiated. And very shortly after that, that sequencer is in control and controls the rest of the countdown toward the desired launch time at the top of the hour. And just as a point of reference, obviously this is a test flight. It's not going to the International Space Station, but as mentioned, there's a great deal of interest in today's launch, obviously with the flight control team here in Houston and mission control, but also up on the International Space Station. The crew typically goes to bed about 4:30 in the afternoon. That's when their traditional 8-hour sleep period begins roughly. But there is hope that if we have good television or KU coverage to the station, the crew might be able to actually watch the launch. At the time of the launch, for a geographical reference, the station at its altitude of about 260 statute miles up in space, obviously, it will be down off the coast of Mexico, just to the west of Guatemala. So that's probably about 1,500 or so miles line of sight to the Virginia Eastern Shore. So, but the crew, more than likely, with the daylight, would probably be seeing a better view of the launch, at least on television. And although they have had opportunities where they've been able to capture some other launches.
MLC on countdown 1. At this time, I'd like to poll for final FTS power on and Arm Command test. Safety.
Safety to go.
Safety is go, FSO.
LC FSO. FSO is out due to toxic, or DFO currently, we just found out.
Okay, are you go, though, for final FTS power and Arm Command test?
We can go through the test, as long as you be aware.
Copy that. FSO is go. Ops 1.
Go for FTS.
Ops 1 is go. Ops 1 is go and electrical 1.
Electrical 1 is go.
Electrical 1 is go and FTS.
FTS is go.
FTS is go. Launch team is go. For final FTS power on, arm command test. Check 362.
So, Kyle, we just heard the launch team get through the poll for FTS ARM, which is the flight termination system.
And FSOLC step 363, bring up command transmitter on primary with tone 4 on.
In work.
So, Kyle, maybe it's a good opportunity here between polls to talk a little bit about the Cygnus mass simulator that we're flying today. You see it in the picture there. Once again, this simulates both the mass properties and the volume of the Cygnus cargo transfer vehicle we intend to carry on future missions. It's about 200 inches long, 114 inches in diameter, and has a mass of right about 8,400 pounds. It's fully instrumented with a full flight set of accelerometers, microphones, thermometers, thermocouples, and strain gauges, which will allow us to fully characterize the payload environments in flight. It's also flying the signatures of a number of orbital employees that have participated in the integration activities to date.
And probably well-deserved, probably tremendous amount of work went into putting any mission together, but obviously this first one, and so it's well-deserved, I'm sure.
Yeah. And then also flying on board the mass simulator today are 4 secondary payloads. 3 of those payloads come to us from the NASA Ames Research Center. They're PhoneSat spacecraft, cleverly named Alexander, Graham, and Bell. And they're each powered by small commercial cellular phones. And then there's an additional mission that is a small 3U CubeSat Dove-1 that's an imaging spacecraft.
And I think that be a good opportunity, since you mentioned the secondary payloads. Those obviously are deployed from the mass simulator after it's essentially gets past its 10-minute mission. Let's take an opportunity to look at a feature of those PhoneSats that you mentioned.
The Orbital Sciences Corporation test flight of the Antares rocket will be carrying a very small secondary payload into space. On board are 3 nanosatellites that were designed and built at NASA Ames Research Center, the lead center for small spacecraft development. 2 of the CubeSats are called PhoneSat 1, and one of them is a PhoneSat 2 Beta.
Someone here asked the question, can we fly a cell phone as the avionics for a satellite and have something that's very capable but really, really inexpensive? So PhoneSat was launched to try to answer that question.
Measuring only 4 inches on each side and weighing less than 4 pounds, each miniaturized satellite was built for only $3,500 each and will showcase the ability to launch the lowest cost, easiest to build satellite ever flown in space. The design makes extensive use of commercial off-the-shelf components, including a consumer-grade smartphone. Out-of-the-box smartphones offer capabilities needed for satellites, including fast processors, versatile operating systems, multiple miniature sensors, high-resolution cameras, GPS receivers, and several radios.
The smartphone vendors have put a lot of R&D money into making very, very capable microprocessors that have a lot of processing power and speed in a package that's very rugged. And we intend to fly it as a microprocessor for our satellite.
NASA's PhoneSat 1.0 is built around the Nexus 1 smartphone, while PhoneSat 2.0 Beta has improved software and more sensors. A Upon deployment into space, each satellite will broadcast a signal every 30 seconds on the amateur UHF band at 437.425 megahertz. The PhoneSat project will be a success if NASA confirms reception of signals from the CubeSats. However, anyone around the world can listen for this signal and upload what they hear to www.phonesat.org.
Ops 2, countdown 1. Yeah, can you go to anomaly 1? Ace, can you meet Ace and electrical, meet Ops 2 on electrical on anomaly 1?
Electrical 1 on anomaly 1.
So that was the small phone sats that John mentioned that Ames sponsors for this flight aboard the Antares, the Cygnus, or the payload as part of the overall complex rocket system. After liftoff, the stage 1 basically flies for about 3.5 minutes before the stage 1 shutdown, then separates a few seconds after that. Stage 2 actually ignites about 1 minute and 38 seconds after that shutdown, at about just under 5.5 minutes after launch. And of course, stage 2 burns for another about 2.5 minutes or so.
Yeah.
Coast out to 8 minutes, and then the vehicle's oriented for the payload separation activities. The overall mission duration is about 18 minutes 43 seconds. Obviously, the simulator mission actually ends right around that time. 10 minutes or so.
Yeah, the payload simulator separates about 10 minutes into flight, and then beyond that, we use our attitude control system to conduct a what's called a collision avoidance maneuver, just to make sure we get the stage out of the way. One thing we didn't mention about the mass simulator is that it's actually going to stay on orbit there for a few weeks before it ultimately re-enters. And the PhoneSat missions are expected to have a similar lifetime of broadcast back to.
We've had a premature separation of the umbilical on stage 2, so we're going to have to abort for the day.
Okay, copy that. This is LC on countdown 1. Abort, abort, abort. This is LC on countdown 1. Abort, abort, abort. Proceed to abort safety procedures.
And well, we just heard on the countdown loop they've had to basically scrub for the day. They've had a premature dislocation of one of the umbilicals on the second stage. And obviously, John, that's that's not going to be a launch today. And then, of course, they'll have to regroup and coordinate planning for turnaround activities, right?
Yeah, that's correct. This will likely be a 48-hour recycle.
And verify master arm enable indicators extinguished on fail-safe panel.
As we discussed early on in the broadcast, it's all intended to be the last in a series of tests, and the further we get through the count, the more we learn each time.
Well, absolutely. A test flight is just that. So work through issues on the ground. It's certainly better to have them here than in flight. So definitely something to work through. So we'll stand by for a little bit and see if we can find out some information for you on turnaround activities and whether or not we'll have a post-scrub press briefing to lay out. Obviously, this has just happened, so we'll stand by and see if we can get you some more information. Again, the launch today has been scrubbed at just about the 12-minute mark of the countdown due to a